Okay, let's wait for another couple of minutes to make sure everybody can join to this session. Okay, let's get started. I think we have seen this video in the last session, and so I have demonstrated this is actually not adopted from movie. It's actually real. It happened a couple of years ago in Europe. Some Europe bank was hacked by some criminal organization. Their dispatch cash from ATM machines from maybe at a predetermined time. A couple of places ATM machine was hacked, and they are loss of hundreds of dollars. So I think that their method is not new. They just to send some emails later. We will going to see that. So this is actually their hacking method. The first one, it will be for the infection, and they just send some backdoor exploit and Troy, and he maybe hundreds of machines infected in the search of. Then they search of the admin PCs for the high permissions. Then they are able to mimic some stuff from the bank to maybe do the money transfer to their fraud account and do the controlling ATMs, and also for the database manipulations. I think this is for what we call advanced persistent threat monitoring. So when we start from the ATM machines, and this is for simulating the mobile transactions, we use those kind of data, and then we insert into data hub. So this is called what we call data hub. Data hub is in Alibaba Cloud. It's kind of like Kafka, and it can insert the data into the real-time compute, which is a real-time streaming data processing engine in Alibaba Cloud. And we reference some dimension table, which may be the blacklist. And we want to do a join to see if there's some suspicious account in this list have some transactions. Then we gave the final result into this RDS or the tables, or the table store, which is faster response database, can be Redis, can be HBase, something like that. And we are using the DDV for the demonstration to indicate where is going wrong. So those are a red dot is represent the ATM. There are some suspicious actions happen. So if you want to see some abnormal things happen in this dashboard, you may take some actions to terminate the transaction. Okay, we are going to use our products to simulate this whole process. So we're gonna introduce some product to in this for you to build the whole streaming data process product. Okay, let's just jump out to the Cloud Console. Okay, there are several steps. Let's take the first one, which is for the data hub. Actually, we are using the SDK to simulate data from ATM and maybe mobile device. So we are using SDK to do that, which is a Python SDK of Data Hub. Okay, let's first go to Data Hub to take a look at that. I was saying that the Data Hub is actually just like the Kafka in open source in Apache. It is just like the Kafka, and they share the same concept. Like this is actually the dashboard for the Data Hub. We go into project. So in project is actually just like a database, and we already have two projects. We go into this one. We can create topic. So this topic is just like the topic in Kafka. But in the Data Hub, you can create a topic just like you create a table, and you can define the tuple type, or if there is some videos, audios data, you can use some blob type of this topic. So now we are just to transfer some task messages. So we're just using tuple. So this is fulfilled, like the IDs, you're gonna strings, and you can add in for another column, and then you're going to create one topic in this Data Hub. So we are going to use this one. We can see there's a lot of data in this. This is a table schema information. You can just think it as a table. A table schema, the first column is transaction ID and UID, and this is the card, bank card information, and this is how much the transaction amount of money, and this is the bank belongs to the transaction status and some geography information. Okay, we also have a short list. So what we're going to do is we're using this Data Hub Python SDK and simulating some transactions from ATM machine at the mobile. So we are using this Python code to do that. I think maybe some of you have already seen that. And we are insert this transactions every 5 seconds. So we can see what is going on. And we insert the data into Data Hub, and Data Hub immediately send the data into this real-time compute. We are going to log on to this real-time compute. I will change to English version. You can see there's one job is running, which called fraud detection. We go into that, and we can see the job status. It is actually waiting, some data is coming. So it is actually a join using this Data Hub tables. You can see from here, Data Hub tables source. And we want to use some RDS, which is MySQL from Alibaba Cloud, use as a reference table or dimension table. We want to do a join, which is a hash join, so we can put the final result back into the RDS. So this is the code logic. If you want to see the detail of the code, you can go to development dashboard, and this is the code for Flink. It's just real-time compute. You can see that as well. So you can see that it's totally SQL statement, and it is not let you, if you're not familiar with the Scala or Java, it's okay. If you're familiar with SQL, you can easily to build a real-time detection project. So this is the real-time compute, and we are going to use the DDV to do the demonstration dashboard. So we jump into the DDV. We can see there is a dashboard. Already presents some abnormal red pot here. So that's the whole, because now we are no longer the data is inserting, so there's some data listing here. So we want to present the whole demo. We just we need to go to the database, because we store something in the database, and the DDV, this dashboard, is actually reading some information from the database. Okay, we go to the RDS console and try to log on to this database. This is the RDS console. We can see there's an instance ID, regions information, and the public endpoint. You can connect this from the public connection. And we goes into log to DB. Here, this log to DB. And then we goes to DMS, which is a data manipulation service. We can see there is a different instance and database here. And we have three databases. One is MySQL and information schema. I think if you're familiar with MySQL, that's you can the database you usually see that we are newly created. So this is Academy DB is our data is located. In this database we have three tables, and this alarm customer is stand for the blacklist. It's a dimension table, and this demo anti-fraud demo is what the actual data is in. And we got the final result, so to indicate the bad things happen here. So that's where we can select to this anti-fraud result. Sorry, I can select this whole line. Execute. You can see there's some actual lines here. So what I'm going to do, I will double check this dashboard. What I'm going to do to truncate this table, that means we delete all the lines, all the rows from this table. Just truncate. And when we select this table again, you can see there's no data in this table again. And we switch to the dashboard, you can see nothing happens. And let's simulate some bad things happen using this SDK. This Python SDK is actually, you may need to install the DataHarp packages just using the pip install DataHarp. I think we can easily do that by to read this document for reference, because it's real can set up. Oh, okay, this is the demo code. I think we will go back to the readme document. You can just install PyDataHarp, and you're gonna to use that. These are the packages that the PyDataHarp is rely on. So you can follow the instructions and build your own packages in Python. Then we follow the instructions to enter the access code. Like this is access ID, access key, and this is the endpoint. And we build a DataHarp connection. and we gave it a project name, and this is a topic name. So we can switch back to our data hub. You can double check. So this is our project name, which is RT compute, which compute is, I think the spell is wrong, but it doesn't matter. And okay, this is the RT compute. And in this project, we have this topic. In the project, we have this topic, right? Anti-fraud, demo 2. Okay, the shot is 4 and sleep time is 5. That means every 5 seconds it will send one transaction. Okay, then we build this connection and read this data. So this is actually one data from local file system. Okay, let me take some. Let's take a look at to this data. There are several lines here. I think the first line is transaction ID. Just like this. Sorry. Let me open that here. We can take a look at to this table schema and to take a look at this data. So this one is actually the transaction ID, and the second column is the user ID, and there's a card, and this is the amount of money that this transaction is gonna to transfer. This is card bank. Yeah, just the fake. This is our fake data. And this is the status, and this is the longitude and latitude information, something like this. So this is actually the data we want to insert into data hub. Okay, let's to do that every 5 seconds, and then we will jump into this to monitor if it is real going on. Okay, let's get started. Okay, so we can detect the first one and the second one. I think it is still inserting. Okay, there's some warning message, but it is okay. Because some of the transactions are okay, but some of them are from the blacklist, so we want to demonstrate that. So we can define lots of other logic in the real-time compute, like the same ID or the same bank card is actually issue the transaction from different locations. It is just not reasonable, so you can give it a warning about that too. So this is actually the whole process going. Okay, I think it is finished. All the data is have inserted. Okay, this is actually, we can use this data hub to gather some data, and using some sensors and any other devices, you can just assign through the SDK to gather the data to data hub, and data hub using some topic. You can subscribe the topic to the real-time compute engine, and in this part we're going to use that to do some calculation and using some dashboard to do some demonstration. So this is the whole process. And for this real-time compute, I think it is don't need too much development, because all the code, most of the code, not all the code, most of the code are generated automatically, like those one, because there are maybe 56 less than 60 lines of data you can build this project. So let's delete those one. Because we want to read some data from data hub. So we want to go to this storage, so which we can connect to some data source. We want to go into this data hub storage categories, and we can see there is one project I can see. And double click this project, we can see 3 topics. So you can also go deeper into each topic, and it will give you a summary information. And there are 3 options, like reference as source table, reference as result table. So that's what we need, that we need to read data from this data hub. So we're going to choose reference as a source table. You can see the code is automatically generated and help you to write down on this dashboard. And then we want to reference some dimension table, which stands for the blacklist. So we go back to the RDS, which is the Academy DB, and there is a result. There's a alarm customer. So we want to reference as a blacklist, which is dimension table. We double click that and reference as a dimension table. It can, I think can automatically detect that. Clicked, so you can see also automatically generated to connect this this RDS. Okay, and for the third one, we want to insert those data into a table, fast responsive database. If it is also, we are also using the RDS, so we double click this anti-fraud result table, reference as a result table. Okay, so that's pretty easy to generate those code, and you can just write down those 4 lines maybe, and we just give it a join, so it is pretty easy logic for you to do that. And for some any other logic, you can also to do that with a few lines of SQL statement. So that's the whole process is going. So not so much programming. You can easily build an anti-fraud monitoring system with your own rules defined. You can deploy more complicated, like in machine learning model in Flink or in Pi, which is our machine learning platform. So for this data, we can also do more things in this data V. So I will go that again. So we are actually provide lots of template for you to do that. Like there's maybe for security. This is for security, and you can represent some attack from all over the world. And also for some smart buildings, you can build a 3D model for your campus or your buildings. There are also for some industries and global trade and manufacturing, something like this. You can monitor each step of your whole process. And this is for the network security. It is represent where the attack is come from and the destination. So it will be maybe for some mathematics and hospitals to do some analysis. So this is for the security monitoring system. So we can using this data V and to do lots of things is also support like the third-party widget, like the e-chart, something like that. This is for the city traffic. So this kind of fancy dashboard you can easily using drag and drop. So our dashboard is actually just using one geography basic map layer, so you can see just here, and we just connect, we put some layers like the breath bubble here, and you can do some configurations like line chart or pie chart, and connect to some database. It can refresh every second to demonstrate the data. Okay, I will just refresh. Okay. So this is a basic map layer. You can deploy some 3 dimensions, so we don't need to do that. And okay. This is the basic map, plat map, and you can easily to change the latitude and longitude information. I think it is listed here. Okay. We go into that basic map layer. We can using this bubble, breath. This is the type, and we goes into the data tab. So we can configure where the data is coming. So there is a set, this set. You can see there's a lot of data source it can recognize. One is static data and the CSV data which you upload from the local. We also can use some APIs to connect some published interface. So here we are using the database. So you just give it a connection, to create a connection at the beginning of the database here. This is the data source. You can just add one data source. It can support lots of data source. You can take the offshore document for reference. So this is I already created to one MySQL. And after you doing that, you can write down some SQL statement to select the data from the data source. And you can also do some filtering and to demonstrate those data. So there are also some other component you may to choose, like the flying route widget. Okay, let me update this one. You can add this component. You can see there's a lot of components based on this map. Very fancy ones. Flowing bubble, the flying routes. You can just define the geography according to its format. It will easily to demonstrate. There's a lot of other widgets for you to choose, like a bar chart. You can easily to using drag and drop and just configure using to define where the data source is. So it's pretty easy once it is connected. The same logic, like this line chart, and we also have some scatter and some other kind of beautiful chart. I think it is cool. You can maybe try about that. I think this product is doing some promotion now. So I think it is the human being's brains is designed to see the pictures instead of some boring data. So once you have deployed those kind of dashboard, I think it is easily to convince some others maybe to cooperate, to do some investment, something like that. So it is, shows you are professional when you're showing some data and using this way. Okay, so we're using this one to easily build a demonstrate, anti-fraud demonstrate with some dummy data. And we're using the data hub. Okay, let's switch back to our slides. Not this one. Not this one. Okay, this one. So we are using some Python code to simulate the transactions into data hub, which is also Kafka, and we insert those data into the real-time compute. And we reference some data from the RDS and give the final result into RDS also, and using DataWay to connect it to this source. I give you some demonstration for that. Okay, that's the maybe the streaming data session part. I think it is you can maybe you can try about that. I think it is quite easy for you to quick start. Okay, that's the one. Okay, that's streaming data processing. I think next step we're going to jump into the Hadoop on cloud, so which is our MapReduce. So in MapReduce we actually have, because you have legacy Hadoop system, the data warehouse, the most popular data warehouse in Hadoop will be Hive. So what we are going to do is to migrate the Hive tables to max compute using our, which we call MMA. The MMA is stand for the Max Compute Migration Assistant. So you can see that we can easily to migrate those data into max compute. And so we are do this demonstration to just to introduce. One is MapReduce, the other is max compute. So and these two MMA. So if your customers or your organization want to have pin some suffered from the maintenance and the hard to not focusing on your business problem, by using Hadoop you can try to use the DataWorks and mass compute, because this is totally serverless and cost effective. And the MMA will help you to do that. But if you're very bound tightly into Hadoop, and we also have those kind of option, we have the MapReduce. And MapReduce is using, we provide the separation from storage and the calculation. So there's lots of options for you to choose. Okay, before that, because it will take some time to initiate the environment, so I just click start, and we will go back to the consoles to demonstrate what is MapReduce is. So this is actually the MapReduce console, and there's nothing here because we're going to create a cluster. So this is the cluster, and we can see there's a 4 step for you to create one MapReduce cluster. The first one is software setting, the second one is hardware setting, and it's basic and confirm in the final step. The software setting, you can see that we provide 6 different cluster type. So one is for Hadoop. That is commonly used the Hadoop cluster. And second one, if you want to build a Kafka, so you can choose the Kafka cluster. So you can see there's a corresponding required service is listed here. And there's an optional service you can choose. Like if you want to HBase, you can choose that. If you are using database, I think it is most of the cases you must need a zookeeper. And if you want to do some like the superset to help you to do the storage and calculation separation, you can choose that. Okay, after that you can go next. Before that, I will introduce the 2 advanced settings. One is for Kerberos. That means you enable the Kerberos authentication and authorization service. You can easily to do that with just 1 click. And now we don't want to do that. If you want to do install some third-party software, you can using this one to customize your software installation. And there is a template. You can just in JSON format to write down the template. It will automatically install the service for you. And then it goes to hardware settings. Sorry, I just introduced two kind of cluster. I think the third cluster will be Zookeeper. Data science, you can see there's a lot of science, data science relative components like Pi, like TensorFlow, something like this. And we also have a real-time OLAP, which is stands for the Online Analysis Platform, which is Drury. So we install some Drury component, and this is a Flink. Of course, we support Flink. You can see there's a fixed number of version if you choose one version of MapReduce, right? And I think that the version of this is not flexible. If you, let's say, if you want to, your legacy code is built on Spark, maybe 1.7, so you can choose some MapReduce version which is like this, 1.6. That's me near. Okay, let's try another one. So that's for you to choose different versions of your component. So for hardware settings, the first one is the billing method. You can buy in subscription and pay-as-you-go mode. There's for some regions for you to choose, and VPC network, vSwitch, security group. You can choose that. And this one is high availability. If you enable that, I think it is because it is just like the legacy Hadoop system. It has a high availability based on the services like resource manager in Yarn and the name node in HDFS. So they are quite important service in the Hadoop cluster. So you need to guarantee it does not going down. So there is a slave and master instance. Once the master is going down, the slave becomes the master. And this is the instance, right? In the traditional Hadoop, there's one difference between the traditional Hadoop. Because, as you know, for maybe commercial version like Cloudera, Hortonworks, they're actually one now, and MapR, they actually have the master instance and co-instance, which they can call a slave instance, right? The master instance is usually some very high quality servers with high configurations. So it is used to let the master node running, like the name node in HDFS and the resource manager in Yarn. Because in Hadoop it is a data locality, which is the compute node is actually where the data is located. So it is data locality. But on the cloud, we have a new feature, which is task instance, because we want to take full advantage of the ability on cloud, which is scaling, auto scaling. But in the way of traditional Hadoop, because it's a data locality, it is easy to scale out. Because let's say you have 10 nodes in your cluster, but the peak hour is coming, like the double 11, double 12, something like that. You want to deploy 10 more servers in your cluster. But in the legacy Hadoop, the data is actually expanded to the 10 new servers as well. So the data is easy to scale out, but it is not easy. It's not easy to shrink. Let's say after the double 11, after the double 12 peak hour, you want to release those 10, but the data is already on those 10 servers. So it is not easy to shrink. The task instance is designed for this scenario because the task instance don't have the data, just to help to do the scaling of calculation. It does not have the data. So that's the differences between those three kinds of instance, which is master instance, core instance, and task instance. I believe there are some questions may ask you what is the differences between those instances. Then you can make your choice. Okay, you can also choose the GPU if you want to deploy some deep learning applications. And there are also some different kind of storage for you to choose. Okay, next step, we go to basic settings. Now we can give a cluster name, cluster name. And this one is for you to use a Hive metastore database, because Hive in Hadoop, there's two kind of data in Hive. I believe in every database, and also I believe in every file system, right? Okay, let's take this for example. This is actually my laptop is actually in Mac. Mac is actually Unix system, right? So in this, let's say we touch a new data, right? There's nothing in this A file, right? We remove A, there's nothing. But there's some data to describe this file, like the state A. So you can see there's I believe this is inode in Linux system. This is a permission, this is the owner group, and some different timestamp like the change time, modified time, and create time, something like that. This is the size of the data. I think those data is what we call metadata, right? Metadata. And if you want to write down some data like ABC, just some testing data to this A, I think those are real data. So you can see there's two kind of data. One is data, one is metadata. Metadata is the data to describe another data, right? This is kind of tricky here. Okay, just to try to explain. This MySQL database, three kind of MySQL database is used to store the metadata of Hive. And because Hive is actually a data warehouse in Hadoop, and the data in Hive is actually stored in HDFS, right? And the metadata in Hive is actually stored in MySQL database. So we provide three options for you to store your metadata. Building MySQL, which is the first operation. So it is just one single instance building your ECS. And we also have, you can deploy the RDS, which is the Alibaba Cloud MySQL services. So we recommend, if you're in real production environment, we recommend to use RDS. And this is in a shared RDS. So this is not exclusive one. This is shared RDS. This is exclusive for you. And this is a built-in one, just for testing and development. Okay, this is the type of the metastore. And we're going to assign public IP and remote logon. So we can just give the key pair or define the password. And then next we confirm. After you agree with the service term, you can create your cluster. It will take maybe 10 minutes for you to create this cluster. Okay, that's the whole process of how to create a EMAP-produce cluster. Okay, let's jump into this lab environment. Let's try to use this migrate the Hive tables from Hive to Max Compute. Okay, So this is actually our lab platform. There's some instructions here, and we just follow those instructions and to do the whole process. Okay, let's do that. It will generating one sub account. We can just copy paste. This is the password. You can just log on. So this is actually, it will jump into the real Alibaba Cloud environment. So you can see from its URL, right? You can see from this URL. And first we want to create one project in DataWorks and Max Compute, because usually we use Max Compute through DataWorks, right? The Max Compute is just like an engine, and DataWorks is a user interface. We switch to US Silicon Valley region. So we create a workspace. So this is just actually the DataWorks, right? Demo, maybe 06. Okay, so we choose Max Compute, maybe Pi also. We go next. Display name and also demo 06. Okay, we choose that and we create a workspace. I think it will take some time to create that. And we switch back. Okay, this is we will go to the Cloud Console. English. And we goes to console page. Oh, this workspace is done. So we go back to the workspace. So the status is normal. We directly jump into this workspace. And the whole is actually Max Compute, because we chose the Max Compute as its compute engine. There's no tables here because we are already introduced where to find the table, right? This is a tenant table. There's no table listed here, no data, right? Because we only want to, yes, no data. Okay, so we want to migrate some data from the hive to Max Compute. So we are using the eMapReduce to set down the hive environment, because hive is actually in Hadoop. eMapReduce is actually a cloud version of Hadoop, so that makes sense, right? Okay, we go to eMapReduce console. eMapReduce console. Oh, you can see that we already have a cluster created. So this is the cluster we created. Okay, we directly goes into this cluster. Just click the cluster name. Those are the information for this cluster, right? You can see there's software information and some basic information for this cluster. That's the cluster name, if it is high availability or not, charging method, its ECS role, how much time it takes to since its last start. Okay, you can see there's a 3 node for this cluster, Hadoop cluster. One master node instance is 1, right? And the core instance, which is there's 2 core instances, right? And we do not have a task instance for this case, but you should have if you are in a production environment. Okay, so this is one. You can see there's a public IP address. That's for you to connect. Okay, we are try to use this public IP address to connect. Okay, we open another tab. I will try to enlarge so that you can see that clearly. Okay, we are using bash. We using the root to directly log on. Okay, yes. I believe I remember the password. Oh, sorry. All right, let's go back to the documentation to check if it is the password is yes. Let's copy paste this one. Right. Okay. Finally, I got onto this Hadoop master node of this Hadoop cluster. So we can use the GPS. You can see this is there's a name node here and the secondary name node. That's usually what we do if you're not using the high availability in Hadoop cluster. There's a name node and secondary name node. We can also see there's a resource manager, right? Resource manager, and the resource manager is actually the very important services in Hive. Okay, so we switch back to we want to generating some data here, right? So we want to create some Hive tables in the Hive database. Let's do what the instructions told us. Let's make one directory called data, right? We go into this data, and we want to generating some data. So there's a Python code to help us to generate this data, which it is called create_data.py. So we just copy paste the whole the code. Okay, this is the whole code. We just save and exist. And I think I can use Python to do something like this. It's actually generating this one data with 3.8 megabyte. So let's take a look at this, maybe 10 of the data. What is data looks like? It is maybe stand for some ID information and school information and class information. Those are some some scores that students is maybe for English course, maybe Chinese course, and the mathematics course. So they want to do some statistics. Okay, that's what we have generating those data. And we want to using Hive to create some tables. So the first thing we want to go to look at the Hadoop. So we are using this command line interface, like the Hadoop address and the LS to the root directory. We can see that there's already have some directories, right? And users. So we want to create a new directories just in this root directory, just using the make_dir, and I believe yes, mkdir is the same as Linux operating system. So let me check what is the directory name. Okay, it is my data, right? My data. So you can double check if it is this Hadoop HDFS directory is already successfully created. Okay, so we can do that. And then we can upload to this file. We upload this file. So what we just created, did.txt. We want to upload that using put command this data file into my data directory. Okay. Sorry, something is sorry. This is a put. And we check again if it is we upload successfully or not. Okay. Here the right size, and we successfully done that. Okay, I think the next part we are going to use Hive to create some tables. So we directly log on to Hive just using the type Hive, because you are in the master node of your maybe Hive service. So you can see the Hive current version is 2.3. Okay, we want to create some, first we want to create some database, right? Let's check what is the database name using this one, and we create this table, right? I just copy paste this DDL. First we create, okay, I stuck from here. It cannot respond, right? Okay, I just click that, reconnect again. Dash, let's enlarge that, and we SSH. We go back to the console and get the public IP address of your MapReduce cluster. Okay, I think the server is not going down, and we copy paste the password. Okay, great, and we log on to Hive. We show database to see if everything is okay. Unable to. Okay, let me do that again. Right, let's try to create one database again. Try to do that. Create database. Sorry, wrong. Create database. Something's happening. Show database. Okay, I think I need to maybe restart the Hive services to let something is gone wrong to Hive. Okay, let's go into the Hive service. This is actually the MapReduce console. Let's go into Hive. Oh, you can see that the Hive servers are actually done, right? Let me start that. So failed. Just start. Let me try to get to this metastore also. Okay. Start. Because metastore is used to connect the to manage the metadata of Hive. You can refresh. I think we can try to restart Hive server. terminal plan. And also to restart this metastore. Stopped on error. Let's wait for some time to let it come back to normal. Okay, let's try to I think I disabled the covers, right? Okay. It just stopped. And let me try to start. Configure. Stop. Let's try to stop all. Okay, stopped. How about we start the whole cluster? So that's the last thing I need to do, right? So we something is going wrong. Use this data restart cluster. Rolling restart. You can see that we support rolling restart functions. Restart skill node. Okay. I don't think I have the permission to do that. Okay. How about we do that again? We stop this, release those whole this lab and to do that again. Okay, we shut down those. We go back to this lab. We join this course by purchase, confirm, and we view documentation, start lab, launch. Okay, that's why I don't need to do the live demonstration. Something will go wrong. You never know about that. Okay, let's log on to this console. Password. Okay, first we just check the eMapReduce status. I think the cluster is during initialize. Change to US Silicon Valley. Okay, let's go to the DataWorks. Okay, we create one workspace. Demo 06 and 19. Basic mode, next. We select max compute, pay as you go, and also Pi. We go next and give it a display name like demo 06. We create a workspace. Okay, we go to this map-reduce. Go to cluster page. I think we can assign row in RAM. Okay. I think it is ask us to assign some rows for that. Okay, this workspace is created. Okay, let's go back to this map-reduce. I think they may change something in the back end. Okay, no worry. I think I have plan B. I have plan B. So I recorded the video. I recorded the video actually to deal with the situations like this. Okay. Okay, let's see the normal process for that. Usually we just this MMA is just tar packages. We just download that, and you can enter. You go into that. You can see there's some configuration file, which is we can go into this ODPS configuration file. Those information. Okay, that's too fast, right? Okay, those information are we need to enter the ODPS, which is max compute project name, right? In here, and the next is access key and access ID and endpoint. Those are the connection information to tell the tools, which is we call MMA, to connect to max compute, right? Okay, we continue. So we switch to the max compute demo, max compute console to fetch the information. Okay, we goes into the max compute. And here we also create a workspace first. We chose those information and we gave it a name. I think we choose some other configurations here and we create a workspace. Okay, we goes into the data analysis and fetch the information like the access ID and key. So those are the informations I already fetched. So we want the project name, access ID, and access list. I actually blurred the very sensitive information. Nice move. Okay, we after configuration of the file, so I go to the map-reduce, the DIT platform for the map-reduce. We go to this DIT platform in the map-reduce. You can see that I have created one hive query here. So this is actually what is like what we have do in DataWorks. The map-reduce have the same functionalities, because you can use in drag and drop and create some Hive and Spark or MapReduce jobs here, and you can also create ad hoc queries. So we show tables here. First, show database. It will ask you which cluster you're going to run this command, because we can manipulate several command line here. So let's begin to do the migration. So this command is, let me give you a little explanation. So this is the Hive, HMS is stand for Hive Metastore Service. And you can give it as a Hive Metastore Service, which is the local and 90883. If you're familiar with Hive, it's pretty popular for Hive. So the mode is for single, which means it's a single table. And the data source is Hive. Hive database is this name, and Hive table is a e-score. And the destination is Max Compute Project, which is MMA demo, and the destination table is e-score. So that's the whole process is going. Okay. So we finished doing that, and we switch back to DataWorks. We can see that we can create a query, so we can query the table in the Max Compute to check if it is successfully imported or not. We can create a SQL statement from this e-score, because we have the name of the e-score. I think they're gonna be run because I'm not sure we have the permissions for this table. Okay. Oh, everything is fine. So this is for a single table. What I'm concerned is, because we don't have much permissions for the table, and we need to apply for the permissions. But I think I already done that. I didn't put it. I just skipped that steps in this video. So we back into the MMA, and we wanted to import more tables at the same time. So we just created this map configuration file. So it will do the mapping. This side is too quick. Let's go back a little bit. So the comma, before the comma is the Hive table, and after the comma is the Max Compute table. You can do the mapping, so it will transfer the data as your configure. So this is the well-performing. Okay, first done and second done. Okay. We go back to the DataWorks and to check the tables. We can see there's maybe 2 tables already imported. Okay, I think that's the whole process of the using MMA to help you to migrate the data from Hadoop, Hive into Max Compute. And in the new version of FMA, I think we will demonstrate later. It will contain, you can import the UDF of Hive, and also if you have a large amount of data, it can resume the connection if once it's terminated during the transformation. Okay, that's the eMapReduce. We're using that for the eMapReduce and introducing this Hive migration, this Hive to Max Compute migration assistant. And I think we need a break. And in the last session, we're going to introduce the Pi platform, which is a machine learning platform. And we are going to, I think that's an important part for who is wanted to take the ACA examination. We can explain some key point of the ACA certification, and then we go through some sample questions for the ACA. Okay, how about we take a rest? I think it is maybe hard part for you. This session is a little longer. And how about we take maybe 12 minutes break? And for Indonesia, we come back and maybe at 3:10 o'clock, and Singapore maybe come for 4:10, and for India, let me do some calculation, maybe 1:40 p.m. Okay, let's take maybe 12 minutes break. Okay, see you guys later.